Example 5. A particle is moving along a line with position function s of t. Part A, find part A, velocity, B, acceleration, and C, describe the motion, okay, when time is at least 0. So just positive time frame. So let's find our answer to A. We want velocity here. So we want it to be v of t equals. Part B, we want acceleration. So A of t equals. And then this is where we will be describing. So the velocity is the first derivative of position, students. So that's going to be -2 minus 2t. We got the answer, -2 minus 2t. Then acceleration, guys, is going to be the derivative of velocity, which is second derivative of position. So that's just going to end up with a -2. So it looks like acceleration is always going to be negative. So when we are describing the motion, guys, we do need to know where is the particle at when time equals to 0. So time equals to 0, this is 0, this is 0, so this is just 6 units, okay? So the particle starts at 6 units to the right of 0. Now we need to know if it goes right or goes left. Now to go right, guys, then that's when the velocity, it's going to be positive. So we want to take the velocity and we want to set it equal to 0. Now to set it equal to 0, we're going to move the 2t to the left. So we are going to find what's happening. Okay, so now t equals to -1 because the restriction is time's got to be at least 0, but -1's right here. So what happens to all of the time? So when we plug in, let's say 2, 3, 4, 5, the whole velocity is always going to be negative. So it's always going to go left. Now we also are interested in, hey, is it speeding up at all? Well, speeding up is when the velocity, guys, and acceleration are the same sign. But look at this. This is negative. The whole thing is negative. So it looks like it's speeding up and going left indefinitely. So after we find that the particle starts at 6 units to the right of 0, guys, it speeds up, and goes left indefinitely. So let's try that. So first derivative, which is your velocity. Okay, that's the velocity, which is 6t minus 6t squared. And we're going to write that down first, okay? So velocity equals 6t minus 6t squared. We need to box that up because it's asking for velocity. We will solve for t. We will factor out the 6t, so that's going to give us 1 minus t equals to 0. 6t equals to 0. 1 minus t equals to 0, so that means t equals to 0. And then t equals to 1. So there are 2 time frame here that this object will take a break or turn around. So we are going to make a number line for our velocity. So here's 0 and here's 1. Let's test it out to see what happens. When your velocity is in between 0 and 1, let's do a half. So we have what? Let's do a half right here because that's easier. 6 times a half, that's going to be positive. 1 minus a half, so this is a positive, times a positive, so this is positive. And then velocity at 100. So 6 times 100, that's positive. 1 minus 100 is a negative, so this is negative. We're going to do the same thing or similar to our to find the acceleration. So acceleration is the first derivative of velocity. So we are going to have 6 minus 12t. I'm going to box that up because that's part of the question. So I don't want to forget. Whoa, why did my red one disappear? All right. then we will solve for 0. So 6 equals 12t, divide both sides by 12, t equals 6 over 12, which is a half. Okay, and similarly, because I want to see where it speeds up, remember the time frame, guys, must be the same, okay? So this is acceleration now, and this is 1, so your half for time frame is right here. So we want to do the same thing. We want to plug in between 0 and a half and a 1. So acceleration at in between 0 and a half. So I'm going to pick a quarter at a quarter. And so we can see that, okay, here's 6 minus a quarter of 12 is going to be 3. So this is going to be positive. And then the next one is I'm going to pick 3/4. Okay, so 6 minus 12 times 3 over 4. So this is going to reduce down to 3. So 6 minus 9, that is going to be negative. Then we're going to pick 100. Okay, 6 minus 12 times 100, obviously that's going to be negative. So this is negative. Now the reason I want to do the number line in that way is because I want to see when it's speeding up and slowing down. So from the 0, as you can see here, all the way to the first or the half second, that looks like it's speeding up. Okay, ooh, it looks like that's not a good color because I'm covering everything. Let's use highlighter. Like that, that's better. So both of them have the same sign, both of them are positive, and it's speeding up again from 1 to indefinitely. So when we spell out our describing the motion, that's what we want to say. So that was part A, this was part B, and part C describe the motion. We want to know where the object starts out at. So we want to know, that means that time equals to 0. So S of 0 is 0. All right, so the object, the particle, starts at the origin. Okay, and it starts at the origin, and then the first thing you see here is positive velocity and goes right. And now, as you can see, it goes right, but it also speeds up. Okay, it goes right and speeding up, or speeds up, until half a second, and it slows down. It slows down until 1 second. Remember, it's still going right. Okay, now at 1 second, it's when it turns left. Okay, it turns left, and speeds up indefinitely. Okay, and that's what you got to do.